Hello everyone, it's been a while since I have done a video. I'm happy to be back. I've been learning the Dvorak alternative keyboard method, so my typing's been it's been very slow for quite a while, and it will still be a little slower than usual than my previous QWERTY typing, so do bear with me, but I definitely want to start getting out some more videos as my first set has been pretty well received. So we're starting with the advanced algorithms, and this is systemic difference. And we need to create a function that takes two or more arrays and returns an array of the systemic difference, or a delta, or I actually don't know that symbol myself. So let's get a good understanding of exactly what this means. We have an array with A and an array with B and an array with C. Now, these three items will not be compared all at the same time. What happens is we compare the first two items at the beginning, and whatever that result is, whatever the difference is, then gets compared with its next one like that. So there's essentially a base case lying in here. We always start with at least two arrays. So let's start by looking at how we can write a function that returns the elements that are in one array but not both with just two different arrays. So the first thing we want to do is, because we will be doing more than two arguments, and we will be doing in undetermined number of arguments, I'm not going to have formal parameters. This is something I've done in previous videos as well. Instead, I'm just going to declare the args, and I will make an array from the array-like arguments object. This is the shorthand way to do it. Use an array literal. Okay. So that will give us our args. And we have some more traditional mathematics with set A and set B. So that's what I'm going to call the two sets that we will begin comparing. Let's declare set A. That will always be our first argument, or args of index 0. And set B to be args of index 1. Okay, so now we have our two sets. We gotta begin to compare them. How do we do that? Well, if we see these two sample sets here, we want to go through each element and see if it exists in the other element. That's not too hard. I'm going to do that starting with set A, and I'm going to start using array methods with callback functions instead of for loops, for instance, since we are advanced in our algorithms now, and we should all know the array methods at this point. So let's pass in this function. I'll name it num for each number in set A, and we want to check to see if a given number in sum A, or set A, I'm sorry, is not in set B. So let's compare the set B index. We use our simple index of method, index of num. So in this case, it's saying, is there an index in here? And what I'm going to do, because I already know this is going to get more complicated, is if it's not equal to -1, or in other words, if there is an index of the number in set A also in set B, so this would be a number we don't want. We only want things that are in one but not the other. So if set A, or if set B contains an element that's also in set A, we are just going to move on to the next function, or to the next number. Since this is inside a callback function, we can just hit return, and that will short circuit this whole callback function here. It's akin to saying continue in a for loop. And if that isn't true, we just skip the return. And so then we get to a point where we want to add this number to what the difference is. So I should also declare another variable up here, which will be our return. This is going to collect which numbers have passed our check. So down here, we'll say diff.push. And we will push this number that we've been comparing this whole time. Add a semicolon there. So that will essentially filter out, this one here. It will filter out the 2. It will not filter out the 3 because this is unique. Let's run this function. See how we do so far. So we got to remember, of course, let's actually return the variable we want to return. Let's run it again. So we got all errors. We only got a 3. One thing we want to do is we are comparing these here, but we are not yet comparing set B to set A, and we need to do it in both sides. As it showed here, it identified the unique value here, but it did not identify the unique values here. So after this, we're going to do the same exact thing, but with set B. And I'm just going to copy this function I've done here, paste it in, and do the same thing for set A. So we've done the exact same thing as before, but this time we go through each number in set B, see if it's unique compared to set A. Let's run it again, and we got a few passes, so that's great. Now if we look, there's another issue in this right here, and we can actually, I can test it in here. If we have the same number, like that, and we run it, as you can see, we get this number twice, and we don't actually want that. So not only do we want numbers that are unique between the two, but we only want the numbers that appear, we don't want to duplicate these numbers. Now bear in mind, because there's 2 ones here, it does not mean we should have no ones, but we should only have a single 1. So any things that are repeat in the same array, we just want to ignore the next ones. So what can we do? Well, let's think about this. If we're going through this and we're using our callback function here, and we are taking the number and pushing it into our difference array. So in this case, we start with 1, and 1, 1 it gets pushed to our difference. Now we're on to here. We can now compare this to this diff array, because this diff array is going to have only unique numbers. So therefore, we can then use that as a second rule to make sure we're not pushing the same value into the diff array. So I just got to add another if conditional. And now I do the same exact thing, but we check in our diff array. The same thing, because we want to make sure that the number does not exist, and not equal to -1 means that it does exist. So if that's the case, we don't want to add a dupe or a duplicate. So we'll return short circuit it there. Add that to here as well. And the second statement is actually just the exact same thing, since these are both being consolidated into one array. Let's run that. Now my test looks a lot better. There's a 1 that is a 1 that's only unique. And For now, let's assume this will pass, because this is correct. This one here is not working because we have 3 arrays, and right now we've only built this function for 2 arrays. So we have these 2 arrays right here, these 2 tests, each with 2 arrays, and these seem to be working fine, so that's great. So what do we need to do now to make this work for more than 1 array, or more than 2 arrays, I'm sorry. If we had another one here, and we are already getting the return of these 2 right here, we can compare this whole return statement to this right here. So this is a great opportunity to make a recursive function. We already have our base case. Now we just need to elaborate into more than the base case. So what do we test for? What is our base case? Our base case is that we have 2 arguments. So let's test it this way. Remember up there we had our args in an array, and this is an array of arrays. So if args.length is greater than 2, or if we are not in our base case, I'm just going to put non-base for now. Otherwise, we return the diff. And I don't need to put an else down here because in our non-base case, we're going to return something ourselves. So how can we call this recursively and add on to the array that the diff array we've already done? Well, we need 2 things. We need our diff array because that's going to be our first argument, right? And then we want all the other arguments that might follow it. Remember, this could be a lot more arrays with numbers in them, but we're going to compare these 2 to the next one. It swallows that all up, compares it to the next one, etc., etc., etc. So one way we can do that is we want to compare this to a slice of the args. Remember, slice on an array takes 1 or 2 arguments. We're just going to use the first argument. If I put 2, that tells us where to start the slice from, and it's inclusive. So from a 0 index, we go 0, 1, 2, and we start at this argument. So we have our first argument here and our second one here. Next, we want to put this back into the function somehow. So we can concat these 2 things together. And concat's a little weird because even though this diff is already an array, if I do this, concat, and get this set of arrays is going to be inside this diff.concat. So I want to put this diff in an array itself. So this is an array of 1 array, and this is an array of more than 1 array. And the concat in between will bring this into an outer array consisting of the inner arrays that we have been using systemic difference on. So then, of course, we want to return, and we don't want to return just this call of the systemic difference. We want to call .apply on it. And that takes 2 arguments. That takes what to use as the this identifier, which we are not using. And the second is an array consisting of what the arguments are. So instead of just listing it like we originally did, these arrays of arrays, we can list it like this. 1 outer array consisting of the arguments, which is what's happening inside here. So now we have that for our non-base case, and if not, we just return the difference. This will eventually keep reducing it down until we get to 2 arguments. Let's try running that test, and we are all out of gum. All right, That's my first shot at one of the advanced algorithms. It's definitely more harder, of course. So I hope that all made sense. Let me know how that went, and see you next time.